Hello, welcome to LeetCode Solver. Today we are going to solve 30th problem in 30-day lead coding challenge. And problem name is too long. Let me open the problem. Check if a string is a valid sequence from root to leaves path in a binary tree. Okay, the problem name itself describes the problem. Given a binary tree where each path going from root to any leaf from the form a valid sequence, check if the given string is a valid in such binary tree. Okay, so there will be a tree provided and array provided, and the array 0 1 0 1, and we have to check whether there exists any path from root to leaves which includes the given sequence in a sequential order like 0 1 0 1. Okay, so the way I'm thinking right now is what we can do is like we can do a recursion, and in recursion we will be interested in left child and right child, the result of left child and right child. But here we have to pass extra information to the child itself in order to make decision for the child. Child will make decision, and we will based upon the child decision we will make decision. Like when the child node reach till the like when the child node is a leaf node, and we have to provide another information as well, like what is the index, like root is at the 0th index, and when we level down one child, this will be one index, this will be two index, so index will be incremented, and we will provide the information to the child, extra information, so the child will make decision based upon that. When we provide extra information of index to the leaf node, the index must be, when it is a leaf node, the index must be uh, the total size of the array minus 1, 0 based upon 0 index. So if that is the index, and if it reaches to the end, then it will return us a, like saying it is a valid. So say for example we can return true, false. So if it is a valid, leaf node will return as a true, and this true will propagate till the root, like it is saying it's true. And we already did this index and the value mapping before giving call to the child. So it will return true, and one node uh, will calculate the validity based upon either one of the child is true. Like if there is another child, say left child, which contains, okay, which contains 5 or something like that, then it will not be a valid. So that 5, that another child will return as false, and this node will make decision based upon whether any of the child is returning true, is I mean valid. So based upon that, it will be a valid, like if one of the child is valid, and this validity condition will propagate to its parent as well in the same manner, and whenever it reaches to the root, then root will say if one child, either left or right, is valid or is returning true, then it will return true, saying that it is a valid. Well, in this way we can do recursion, and the complexity will be big of n, as we will be accessing only one node only once, not more than one. So, and each phase complexity is, if it is a binary tree, then big of log n, and yeah. So as we can see, we can also, these are the invalid cases where there is match of 0 0 and 1 is not matching at all, and 0 0 1 0 0 1 is matching, but the matching node itself is not the leaf node. So when it reaches to the leaf node says that the index required is 0 1 2 3, but the 3 is out of range for the given array. So in this way we can solve the problem. Let's go for coding. The length size is 5000. Okay, but node, this is array length, and tree node size is not given, but it also doesn't matter because if array length exceed, then we will not proceed further. So let's go for coding. We also need a, let's say we need a helper function, valid sequence helper. We will pass root index, 0 index in the beginning. So root will need to check with 0th index of the array. So definitely we will pass array. Well, so is valid sequence helper. Say is valid sequence helper. Well, we can formulate this as sequence helper which contains tree node index and vector. If root is null, then we can simply say we can return false. If root is not null, if root is a child node, then say if root is child node, say leaf node. If is leaf node, let's define if is leaf node, which is also boolean. If both children are null, then this is a leaf node. Return true. We can also return ternary operator, like if this is true, if this is the condition, both are null, then return true, else return false. Well, if it is a leaf node, then the index must be if index is equals array dot size last index minus 1. If this is the case, then we will return true. Well, first of all, we have to check whether the value is same or not. So let's say we can also check that before in another if, because it will also applies to non-leaf node as well. So if say index, we can also let's write down all the boundary condition. If index exceed array dot size or equals to array dot size as well, then we can simply return false. But if also we can check this condition over here as well, array of index is not equals current value, the root's value, so we can simply return false. So if we do this checking, like checking with value, checking with whether the index will go out of range or not, this kind of checking happened before. So here we will check only index is equals array size minus 1, then return true. Otherwise, we will return false. Well, if it is a leaf node. Now let's do we have all the information, all the base cases we already wrote down. Based upon the base cases, our nodes will make decision and and so this is a base case, and these are the boundary conditions. Well, for this base case, which will reach the leaf node, it will return true or false, and that will be propagated to the parent. Say let's left result, say left result equals same thing is valid sequence helper. Now we will see whether left child is valid or not, and index will be increases by 1, array will remain as it is, and say right result. Same thing. If any of the child is true, then I will return true. Yeah, simply I can write ternary conditions. If left result all or right result, if any one of them is true, return true, otherwise return false. Well, in this way we can solve the problem. I think let's run the code. I think it's okay, but there may be compilation error. Okay, node left node, oh sorry, this is root. Well, root, let's see, finish, no compilation error, true true. Let's try with custom test. To this is checking this, which is first case 0101. Let's try to check other cases as well. In this we are interested in 001. Okay, 001, it should return as false. Well, in the same tree we are, yes, in the same tree we are now interested in 011, which should return as false as well. Okay, false, right. Now in the same tree let's make 0110. 0110, it should return true. 0110, any of this, like it is also returning true, it is also returning true, and this child will make decision based upon any of them is true. True. Let's submit the problem. Accepted. Well, let's check 88 millisecond and 49 megabyte memory. Awesome. Well, as I explained earlier, the time complexity of this solution is big O of n. Say time complexity big O of n, and space complexity is big O of log n, because the tree is a binary tree, and the binary tree, given a binary tree, each path going from root to any leaf. Okay, binary tree may be not balanced binary tree, so if this is the case, then it may have a tree like going down, I mean not fully complete binary tree, so it will like one chain which is just going left children, left children, left children. If that is the case, then their stack will hold all the information till the leaves. Like say this is a chain, fully chain, which has only left child, and there are n nodes, and n nodes, all the nodes are going down. So if this is the case, then it will be big of space complexity will also be big of n in that case. So considering worst case, we can say both space and time complexity is big of n. Okay, let's yeah. Is there any optimization we can do? Okay. Anyway, so I mean, if you have any questions or if you have any optimization or any alternative solution, please feel free to comment. And yeah, thank you so much for watching this video. Feel free to subscribe. And this is the last video of 30-day lead coding challenge. And I also saw that LeetCode is arranging May coding challenge. Hopefully, I will also uh, make videos starting from the May 1st. Uh, yeah, thank you so much, and see you in the next videos.